All right, hello everybody. Hopefully you're doing okay today. So today we are going to begin our discussion in Chapter 5, Section 6. And what's Chapter 5, Section 6 involves is how to solve and graph linear inequalities. So in the previous sections, we've done various types of inequalities. We've had simple one-step, two-step. We've had compound inequalities, and some of you might have even studied absolute value inequalities. And now we've moved on to what are called linear inequalities. And hopefully these look pretty familiar to you in that they're very, very similar to graphing linear equations, which we did a good bit of earlier in the year. And so if you look at this actual one that I just circled right there, y equals 3 halves x plus 3, you can see that that is something that you should know how to graph, right? So we would start at the y equals mx plus b, and you would start at the beginning point, which in this case is 3, and then you would count your slope up to over 3, and you would put another dot to where you would get, up 3 over 2. I said that backwards. And you would put another dot, and once you had your second dot, you would draw your line. If you look at this linear inequality, it is very, very similar. In fact, the really only difference is you see in this region down here, it's a little bit of a darker gray. And that is called the shading. And so that's one of the two extra things that you have to pay attention to when you actually graph a linear inequality. The first part is the shading, and the second part is going to be when you actually draw the line, whether that line is solid or dotted. So let me show you how this works. As I scroll down here, we want to graph this linear inequality. Y is greater than or equal to 2/3 x plus 1. So the first thing I'm going to do is I'm actually going to write slope-intercept form right above it so you can see how it lines up and we can get our important information from this inequality. So the first part we want is the b. Remember, I call the b the beginning, but it actually stands for the y-intercept. So we want to determine where the y-intercept is, and in this case, it is at 1. Now I'm going to put a dot because this coordinate plane is a little bit tricky, just so you know. That dot right there is the origin. And so we are going to, based on the origin, we need to go on the y-axis up 1 for the beginning point being 1. So I'm going to put a dot right there. Okay, so from the origin, we went up 1 and put a dot. Now I'm going to count my slope, and my slope is 2/3, which means up 2 over 3. So if I go up 2 over 3, that puts me right there. And so now you can see I have 2 red dots. I am going to draw a line, but it's very important to understand something about this. When you draw your line, the line could be a solid line or it could be a dash line, and it depends on what the sign is. So I'll give you an example. If you had a less than or equal to or a greater than or equal to, it would be a solid dot. It would also be a solid line whenever we graph it on a coordinate plane. If you have a strict less than or greater than, it would be an open dot, or it would be a dashed line whenever we do these graphs that we're talking about. So that's the first thing you have to remember about these inequalities is the line, whether it's solid or dashed, is dependent on what type of sign you have. Now, because we have a greater than or equal to, that is going to give us a solid line, just like this. And so you can see that wasn't very great. Let's see if I can do this a little bit better. Close enough. Okay, so there's my line. I am going to put my arrows on that line because that line does go over. Now, it goes on forever. Now, there is one more part to this that is important that we make sure we put in. That is, as I showed you above, when you graph a linear inequality, you need to also shade. And so in this case, it says y is greater than. And so we need to focus in on that. So remember, if we want the y's that are greater than 2/3 x plus 1, we know that 1 is right here. Where are the y's greater than that? And the answer is above the line. And so we're going to shade all up here. Now, the reason why we shade all up here is that's telling us that any ordered pair from the shaded area as well as on the line, if we picked an ordered pair and we plugged it into this equation or this inequality, it would give us a true statement. And so that's the graph of number one. So moving on to number two, this one's going to be done in a very similar fashion. I am going to write y equals mx plus b just to help you out. I'm going to put a little black dot where the origin is just so we know that's the center of the origin there. And now we're going to go ahead and graph our line. I'm going to use two different colors this time when I shade so you can see where that border line is and then where the shading is. So this particular graph, you would start by going down 3 on the y-intercept to the y-intercept and putting a dot. And then the slope is 2. That's our m. We would go up 2 over 1. And you can do that a couple times if you'd like. The nice thing about doing that more than once is it gives you a very clear idea of where that line's going to go. And now we need to decide, should we draw a solid line or a dashed line? In this case, because it's a strict greater than, and we can look up here, but when we have a strict greater than, it is going to be a dashed line. So rather than connecting these dots with a solid line, I'm going to go like this up through the line. And there's my dashed line. You do still want to put arrows on the end of that line so you know that it goes on forever. And the last thing to do now is to shade. Now I'm going to use a little bit of a different color. I'm going to go ahead and let's use green for this. And once again, we need to look at our sign to determine which way we shade. It's always above or below the line. We never shade left and right. Even if the line's really, really, really tilted, it's still going to be above or below because it's based on what it's telling us for the y. This says we want to shade the y's that are greater than where it crosses. So right here, down here at the bottom, this crossed at -3. We need to shade on the side of the line where the y's are greater than that. So we're going to shade up here. So everything above this line gets shaded, just like that. Now, something to keep in mind with this one. Because the line is dashed, that means you cannot pick any ordered pairs on the dashed line. If you were to pick an ordered pair to work for this inequality, you would have to pick it out of the shaded region only. You could not pick one off the line because the line itself is dashed. It's not allowed to be equal to. It can only be greater than. All right, so number 3 is going to be done in pretty much the same exact way. I'm going to write once again the slope-intercept form on there, y equals mx plus b. And then I'm going to go ahead and graph the line part first. And you can see because it's a less than or equal to, it will be a solid line. So that's a little easier to graph on Notability anyways. So the origin is right in the center. We're going to go down 1 and put a dot. And then we're going to go down 1 over 4 like that and put another dot. So there's our 2 dots. I'm going to go ahead and draw my straight line. And you can see goes like that. It is a solid line, as we said, because it's a less than or equal to. And the last thing we need to do is determine which side that we graph or we do our shading. Now, in this case, it says y is less than or equal to. So we crossed at -1, but we need to shade where the y's are less than -1. And in this case, it would be down below the line. So that right there is going to be where you would shade. Number 4, kind of the same procedure. Y equals mx plus b first. We're going to go ahead and graph our line. We start with the b or the beginning, which is at -2. It is the y-intercept at -2. And then our slope in this case, notice there's no number right here in front of x. When that's the case, don't forget it's a 1. So we're going to go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. So there's our points just like that. And it is a strict inequality. It's just a less than. So because it's just a less than, we are going to use a dashed line this time. And then the last thing we need to determine is which side of the line that we shade on. This says y is less than the -2. So we need the numbers that are smaller than -2, which would be underneath the line, because that's going to shade -3, -4, -5, and all that. So there's where your shading goes. So I'm actually going to skip these last two because they're exactly the same as the first four that I just showed you. I hope that made sense. If you do still need any additional help, feel free to reach out and email me. Have a great day.